Welcome to math class, where today we are writing parallel and perpendicular linear equations. This video will cover writing parallel equations. Parallel equations represent two or more linear equations where the graphs of the lines are parallel. Parallel lines have the same slope but different y-intercepts, meaning the lines will never intersect. Parallel lines will never contain a solution point. Some examples of parallel equations. The first graph here on the left, we have two equations, y equals 2x plus 6 and y equals 2x minus 5. We're going to use the left line here to represent 2x plus 6. So we're going to trace over this with our blue line. This is y equals 2x plus 6. The other line is going to be y equals 2x minus 5. So y equals 2x minus 5. For both of these equations, the slope is 2. Okay. For the first equation, the y-intercept is 6, and so that's the m1 or b1 is equal to 6. Our second y-intercept is negative 5. So one thing that we should notice is that they have the same slope, but different y-intercepts. When that occurs, you have parallel lines. Lines that are parallel will never have since they never cross, they do not have any solution points. So therefore, that's what the three triangle dot means. Therefore, no solution. When you're asking you to solve it, you will not be able to solve it. Okay. The middle graph here, we have our two lines, y equals 3 and y equals negative 5. So we'll use the top one. That's our y equals 3. Has a y-intercept of 3. The next line is y equals negative 5. This is y equals negative 5. It has a y-intercept at 0, negative 5. A couple other things that it has, because both of these lines are horizontal, that means our slope is 0. Horizontal lines have a slope of 0. The y-intercepts are going to be 3 and negative 5. And since we have same slopes, different y-intercepts, then we have parallel lines. Now, the other thing about our horizontal lines is horizontal lines are parallel to the x-axis. Okay, the next graph that we have is x equals 3. That one's over here on the right. So x equals 3. And we have y equals negative 4. Or I'm sorry, x equals negative 4. Okay, for this one here, since we have vertical lines, so both are vertical. This tells us that both of them have a slope that is undefined. since the slopes are both undefined, that means we have parallel lines. Vertical lines are parallel to the, rewrite that part, parallel to the y-axis. Okay, but you'll notice they will say x equals a number. Those are going to be the lines that are parallel to the y-axis. The y equals a number. Those are running horizontal, therefore they're going to be parallel to the x-axis. So let's go through some examples of writing parallel equations. First one here is write an equation of a line that is parallel to y equals 1/2 x minus 10, and it goes through the point -3, 7. So the first thing that we're going to have to do in step 1 is to identify the slope. So the slope is 1/2. And so the parallel slope, that's what the little symbol looks like, the number 11 beside the M. Parallel slope is the same. So we're going to put 1/2. Step 2 is we're going to write the equation in point slope form. And then step 3 is we're going to solve for y. So we've identified the slope. That means all we have to do is write down the equation y minus, we're going to go back to our point here. We're going to go ahead and change these values as +3 minus 7. So we're going to go y minus 7 equals 1/2 of x plus 3. We're then going to solve for y. So we're going to move the minus 7 over to the right, make it +7. That goes away. Distribute 1/2. We're going to have equals 1/2 of x plus 3/2 plus 7. We'll finish this out. 7 or 3/2 plus 7. We're going to have to change that to become 7 over 1. We're going to make this 14 over 2. So our final form of this is going to be y equals 1/2 of x plus 17/2. Okay, for this one here, our slope is still 1/2, and our y-intercept is 17/2. And we have different y-intercepts there, so, and same slope, so we have parallel lines. Okay, in this next example, write an equation of a line that is parallel to y minus 2 equals 5 times x plus 3, and it passes through the point 2, -2. So the nice thing about this is we already have the slope, and we already know it's going to pass through this point here. We want our slope to be parallel, so we're just going to keep it as it is. So all I have to do is just set up my equation. We're going to take this as -2 plus 2. So when I write the equation, it'll be y plus 2 equals 5 times x minus 2. We're going to go ahead and move the plus 2 over to become minus 2. Zero that part of it out. Distribute the 5. We're going to get y equals 5x minus 10 minus 2, giving us y equals 5x minus 12.